Okay, the focus this week is on translations in predicate logic, and then we'll do some logical equivalence and stuff, but the focus is translations. And I've expanded on the slides for this section, so if you downloaded them last week, I recommend downloading them again because you'll be able to see everything here, and a few more practice questions were added, and everything's a little bit more spaced out. Anyways, let's talk about how to translate in predicate logic. So I want to start with these two sentences, every puppy is cute and some carpenter is underpaid, because they kind of set up all of our future translations because they're relatively simple in the grand scheme of things for what we can do. And the first sentence is every puppy is cute. Now intuitively I want us to understand this in terms of set theory so we can see how this logic works. Okay, imagine we have a set of puppies. Okay, we're saying every single puppy is cute. So if we have a set containing all of the cute things in the world, then all of the puppies should be in cute. Which basically means, if we think about this in terms of sets, puppies are a subset of cute things. So there's a lot of cute things out there, and every puppy happens to be in that set. Okay, now by definition, this means that if we have an element in puppies, then that element should also be in cute. So when we translate a sentence with every, what we end up using in our predicate logic translation is an arrow. So X is in puppies, we could translate this as puppy X. But we're saying every puppy is cute. So we're saying for all X, if X is a puppy, then X is cute. So this is one way of translating it using set theory and its connection with logic. But there's another way, and I want to illustrate this way because I think it's a great way linguistically to do it because it will work nearly every single time. Imagine we have a sentence here, every puppy is cute, and I have the process already laid out, but I want to illustrate it again just so it's very clear. So every puppy is cute. Now, we have this thing called a quantified noun phrase. So this is a noun phrase, every puppy, but it has a quantifier out front. So quantifier, in later syntax, you'll eventually learn about things called QPs. We don't have a QP in this course, we just call an NP. This is a determiner, every, but specifically it is a quantifier. So we make more distinctions in later syntax courses. In this course, we'll consider determiner, quantifier. We can treat it very similarly. It's okay. So what we can do is every single quantified noun phrase, we're going to pull out of the sentence and we're going to replace it with a pronoun or a variable. It's up to you which one you prefer. So for instance, I'm going to take every puppy out. I'm using parentheses just to say it's a unit, and I'm giving it an index. The index is X, so this is the variable I want to pick. I could pick Y, I could pick Z, I could pick whatever I want. It doesn't matter. Every puppy. Now I'm going to paraphrase everything left inside. So I have is cute, but I need to have a subject position for where I pulled every puppy out. So I can say X is cute if I want to use the variable, or I can use the pronoun it and then subscript it with X. So now we know that every puppy and it, these are related. These are referring to the same thing. Okay, now what we can do is inside our quantified noun phrase, we can break things apart. We can break it into the quantifier. So every, this is like saying every X. We can break it into everything else. So here we just have a noun phrase left, or noun specifically, so we can say this is puppy X. And we can change it is cute, the pronoun to just a variable. So now we get X is cute. Okay, at this point, for predicate logic translation, we can just go piece by piece. So every X would be written as all X. Okay, now we're saying puppy X, X is cute, so this has to scope over those two things. Puppy X, well, any common noun is just going to become a predicate. So we can say puppy X. X is cute. We can translate this as cute X. So it's treated as an intransitive verb. And because we use the universal symbol, we can remember, okay, we connect the universal with the arrow. So for all X, if X is a puppy, then X is cute. So that's how we can think of translating like an every X is Y sentence. Two methods, pick whichever one you want. I like this one where we pull out the quantified noun phrase. because it works whether we have one quantified noun phrase, two of them, three of them, and so on. Okay, let's do this second one, and let's just put off to the side here. Some carpenter is underpaid. So in terms of set theory, this means that if we have a set of carpenters and a set of things that are underpaid, some carpenter is underpaid. That means that there's at least one thing in the intersection. So thinking about this in terms of set theory, this just means that there is some element x that happens to be in the intersection of carpenters and the things that are underpaid. And we know from set theory that if x is in carpenters and underpaid, then that means that x is in the set of carpenters and x is in the set of things that are underpaid. Okay, which means that when we translate this into logic, we're going to use and. So we can say some x exists in x, carpenter, we can just call this carp x, and underpaid, shorten this a little bit and call this under x. So this would be there is some x, such that x is a carpenter and x is underpaid. So that's a method we can use for set theory to figure this out. But I want to show you the same method we did before, where we write out the sentence, we take the quantified noun phrase out, and we pull it out. So this time, I'm just going to use the stuff I listed out on the left because it's already there and we saw the process for 9. So we have some carpenter is underpaid. What we do is we pull out some carpenter and we give it a subscript x. Then we have the remainder of the sentence is underpaid. So we can either say X is underpaid or we can give it a pronoun. I picked he in this case. You could pick she, it, they, really whatever you want. Pronoun doesn't matter. In our next step, we split up the quantifier some and carpenter the noun into two different components. So the quantifier some X and then carpenter, which is the noun. And these are both subscripted with X. So we know that these are bound by each other. They reference the same thing. And we change the remainder of our predicate to x is underpaid, so that way we have a variable. Then we can translate piece by piece. So some x means there exists an x. Carpenter x means, well, x is a carpenter. And underpaid x just means x is underpaid. And because it is an existential, we use an and. And that's from the set theory we saw before. It's in the intersection of those two things. So if you do have to remember anything, or memorize anything, I would memorize that the universal always works with the arrow and the existential always works with and. So these are two simple sentences. Every puppy is cute, some carpenter is underpaid, and simple meaning that there's one quantified noun phrase and then we have a predicate. What happens when we have two quantified noun phrases? So for instance, we have every person. This is one NP with a quantifier, every, and some character. This is another NP with the quantifier some. If we remember back from the very first lecture, we learned about this thing called scope ambiguity. And in logic, we have scope ambiguity too. And that means that there's going to be two translations. The first translation comes from A through C, and the second translation is D through F. So basically how this works is when we pull a quantified noun phrase to the front of a sentence, we can do it in any order we want. So there's one order where first we take the exists a y out first, and then we put the all x out after. So we get this interpretation, and in fact, let me just draw this one out. So this is for every person, there's some character where that person likes a character. So this is the all x exists a y reading. So this would be this reading if you remember it. While the second one, we focus on some character first, and then every person x happens to like that particular character y. So the second interpretation would be the case where every single person likes some particular character. And we can see with how we pulled these out. So we did the same process as before. We index every person with, say, x. We index some character with y. And then we leave our predicate with the pulled quantified noun phrases out, and we're left with x likes y. So that's the original order of the sentence, and we have our three parts. We then go into each of these quantified NPs and we break them up. So every person X becomes every X person X, some character Y becomes some Y character Y, and X likes Y stays as X likes Y. Then we just translate piece by piece. So every X becomes for all X, person X becomes person X. Because we have a universal quantifier, we then use the arrow and we continue our translation. Okay, some character, Y. Okay, so some is existential, Y. Character is just character Y. So for all X, if X is a person, then for some Y, Y is a character, and well, we use an and because we have an existential here, and likes XY. So this is our predicate, X likes Y. So this is one translation of every person likes some character, and it corresponds specifically to this interpretation where there are multiple characters out there, and each person just likes some character or other. The second interpretation, we do the same thing. We pull out the two quantified noun phrases, but we do it in the opposite order. So now Y is coming out after X. So first we extract X, every person X, X likes some character, and then we take some character Y and pull that out. So now we have for some character, for every person likes that particular character. And the translation works the same way. So exists a Y such that Y is a character. Now we're translating some character first. We use the conjunction because we have an existential. Now we're translating every person. So for every X, X is a person. Then we have the conditional because we have a universal, and we get X likes Y. And this translation corresponds specifically to this one. So this is a nice process because the process works no matter what type of quantified noun phrase you have. Just be careful. This only works with quantified noun phrases. You do not pull out things like proper names or pronouns. Those stay in place. But if you have every person or say people like some character, people you can think of as a quantified noun phrase. It doesn't have a quantifier, but it is plural. You're talking about all people, and we'll see some examples of that. So the first question I have for you are why are these translations wrong? What if we use the conjunction with the universal? What if we use the existential with the carpenter? So this one should say all puppies are cute. But what does this actually read? This actually says everything is a cute puppy. So this isn't quite accurate, and this is because of the conjunction. We're saying for every X, X is a puppy and X is cute. So that just translates as everything is a cute puppy. So if we use the conjunction with the universal, we're basically saying that everything is both of those things. B, exists an X such that if X is a carpenter, then X is underpaid. This one is a little bit more difficult to explain. So I want to imagine we have a universe. We have some guy that's a carpenter, and he is definitely underpaid. Okay, now we have someone else who is a florist, and let's say for the sake of, I don't know, consideration that the florist is paid well. Okay, well, in this case, we're okay, because if we have, we know intuitively if some carpenter is underpaid, this should be true. The sentence should be true, because we do have one carpenter that's underpaid, so we have one arrow one, it gives us a one, a florist is paid well, so we have, well, X is not a florist, or sorry, X is not a carpenter in the second case, X is not paid well, or X is not underpaid in the second case, we have 0, arrow 0, that gives us 1. So in this particular circumstance, this works out. But imagine something else. Imagine we have no carpenters in our universe at all. So let's say, I don't know, this is just a salesman, not a carpenter. Okay, well, the existential saying there is something that works, which means it just has to be true for one situation. If we can find one case where this is true, then the entire translation here is true. So here's the thing. We have a salesman who's underpaid. So this is not a carpenter. So carpenter X is false here. But he is underpaid. So we have 0, arrow 1. This gives us a true situation. A florist is paid well. This is again 0, arrow 0, but we get a true situation. Because we have at least one of these being true, that means that this sentence is true. This translation is true. But in our world, we don't have an underpaid carpenter. So in our world, this should be false. But the truth values that we assign to it based on this model say it's true. So that is why this translation for V does not work. So this is the wrong translation for B. We cannot use the arrow with an existential, because if we have an existential with an arrow, then if we don't have any carpenters, it's just true automatically. But we don't want that to be true. If we say some carpenter is underpaid, there better be a carpenter out there, and it better be underpaid. Okay, so the takeaway here, you can either memorize it or understand the idea behind it, is that existential, we use and. With the universal, we use an arrow. Okay, let's talk about translations that are negated. So let's talk about negated quantifiers. For instance, the sentence, no cat is kind. Well, no cat is kind. What this means is that if we take a look at the things that are kind, and we take a look at the things that are cats, there's no overlap whatsoever. So, like, there's nothing in the middle that counts for both of these. So when we do no cat is kind, we can still treat this as a quantified noun phrase because it is. No is a quantifier in this case, and we can still break it up as we did before. So no cat gets a subscript, and we put a pronoun in its place. So no cat, X is kind. We break that up into no and cat. But with no, we can translate this as there does not exist an X. So there is no X. That's another way of saying that. So there is no X such that X is a cat and X is kind. It's a universal, or sorry, it's an existential, so we use the conjunction. With the sentence, not every clown is funny, same thing. Not every clown is a noun phrase. So not every clown. We can split that up into its quantifier, not every, and we can split that up into its noun, clown. Then we have X is funny at the end. And for this one, translating not every X, this just means not for all X. So remember, all X is the same thing as every X. So we put a not before it. And this says, I shouldn't say there. I should say, for not all X, blah, blah, blah. So it is not the case that for all X, if X is a clown, then X is funny. So basically, this just means that we could have something like this, where these are clowns, these are funny things, and what this just means is that there's something out here. There's at least one clown out there that's not funny. Okay, so these are one way to translate the sentences. The only really complicated thing here is just remembering what no means and what not every means. But there's a way to paraphrase these sentences which I think is quite interesting. So when I say no cat is kind, or not every clown is funny, there's always a way that I can paraphrase these so that the subject is not negated. So instead of saying no cat, I can use like all cats or some cat. I can make a translation where the subject does not have a no in it. Not every clown is funny. I can translate this in a way where I just say every clown or some clown. I don't need that not out front. So I want to think about this. No cat is kind. How can we paraphrase this? What's another way of saying this? Well, we could say that every cat is not kind. If no cat is kind, then every cat is not kind. This is another way of paraphrasing this. So if we translate this, what we get is every is going to be subscripted with X. Cat is going to be subscripted with X2 because every cat is the quantified noun phrase. So every cat X, it is not kind. X is not kind. So we can translate this as x is not kind. So now when we translate this, well, we can translate just as before. For all x, if x is a cat, then it is not the case that x is kind. And this would be the end of our translation. So both of these translations are logically equivalent. For no cat is kind, we could say there is no x such that x is a cat and x is kind, or we could say for every x, if x is a cat, then x is not kind, or it is not the case that x is kind. What about not every clown is funny? How does this one work? Well, if not every clown is funny, this means that there is some clown out there. So some clown is not funny. If not every clown is funny, then there has to be some clown that's not funny. So we can do the same thing here. We can subscript some clown, so we can say some clown x, and that will break up into some x clown x. And so for some clown x, it x is not funny. So we can shorten this to x is not funny. And if we translate this piece by piece, we get something very similar to what we did before. Exists in x such that x is a clown, and because we have the existential, and x is not funny, so not funny x. So this is an equivalent translation for not every clown is funny. There is some x such that x is a clown and x is not funny. So you can have either the negation on the quantifier or you can have the negation on the predicate. It is your choice. I would accept both of these. This is not ambiguous. So I should probably write this out. This is not, not a case of ambiguity. Let me just, I have the power to delete things, so let's just use it. This is not a case of ambiguity. This is a case where where there's more than one possible translation for a sentence because these are equivalent translations. So don't mix ambiguity with this. Ambiguity means there's two or more different translations. This is a case where we have two translations that really are the same in the end. So the truth values are the same for these. With ambiguous sentences, the truth values are different. Okay, so that's how we can do some paraphrase. I'm going to do some practice translations, then I'll give you some to do on your own, and I'll go over them from the video, of course. So everything is hot or everything is cold. 15. And 16 is everything is hot or cold. Let's talk about the differences between these two. Everything is hot or everything is cold. Everything is hot is a sentence, everything is cold is a sentence, which means we're going to have two things separated by or. So everything is hot, I could translate this as for all x, x is hot. Whenever we have a word like everything or something, we don't give that its own predicate. If we say every person is hot, then we'd say for all x, if x is a person, then x is hot. But we don't say for all x, if x is a thing, then x is hot. We just take that thingness to be taken for granted in our translation. So for all x, x is hot, or for all x, x is cold. This is how we would translate the first sentence. Everything is hot or everything is cold. Now this is specific. This is specific. Because what this means is that imagine we have a universe of things. So this is our universe. I'm going to do it in black. This is universe 1, this is universe 2. Either everything is cold. So using the standard that blue is cold, imagine these are a bunch of things. Everything is cold. This would be true. Or in universe 2, everything is hot. This would be true. So both of these cases should be true for this translation. In the third universe, where we have things that are cold and we have things that are hot, this should be false with this translation because I'm saying everything is hot or everything is cold. I'm not saying that we have hot things and cold things together. I'm specifically saying everything is hot or everything is cold. The translation in 16 is different. Now we're saying everything is hot or cold. So let me actually just copy this and paste this and think about this in this new situation. So if I say everything is hot or cold, let's think about a translation. For all x, either x is hot or x is cold. It's one of the two. But what this means is that for everything in the universe, it just has to satisfy one of these conditions. So if everything happens to be cold, this is fine. If everything happens to be hot, this is fine. Now, this third situation for this translation, everything is either hot or cold. That means that some things can be hot and some things can be cold, but everything has to be one of those two things. So this third situation is true for the translation in 16. So there is a difference between the two, which are represented by the truth conditions of our third universe here. Or third situation. I think talking about a situation might be more clear, but we've worked with universes before. It's a nice picture. Okay, so that's how we would translate 15 and 16, and these are really the differences between the two. Let me just shorten these up a little bit and keep them on screen, because now I want to do Ben is fond of tall trees. In fact, let me write this one out. Ben is fond of tall trees. Okay, so what we do with this sentence is we treat tall trees as a quantified noun phrase. We can treat it similarly. We're saying trees, we're using a generic common noun. And it's plural. So we're talking about every tall tree. It's just it's implied from this that we're talking about every tall tree. But we have a name Ben. So proper names we don't pull out. So when we pull out things for translations, what we're going to get is a hidden every. So I want to say every tall tree, X. And then in my translation, I'm going to say Ben is fond of X. So this is how I could translate this, is for every tall tree X, Ben is fond of X. So Ben is fond of it. Now, when I translate this, I can do every X. Here's something different. I have an adjective and a noun. Well, if I have a tall tree, I have something that is both tall and a tree at the same time. So I'm thinking of this as tall X and tree X. So for every X, X is tall and X is a tree. And then for this last bit, Ben is fond of X. So I'm going to say Ben is fond of X. We don't have to do anything with that. But these are our three parts. So now when we translate this, we'll go piece by piece. For all X, okay, we have tall tree. So if X is tall and X is a tree, okay, that's our condition for all X. If X is a tall tree, then Ben is fond of X. So I can translate this as, I don't know, say fond of, this is fine. And this is a transitive verb. Someone is fond of something. So we're going to have Ben is fond of X. Okay. So Ben can be the first thing in our argument. I'll call this B. And he's fond of X. So X is the transitive, X is the direct object here. It's the direct object of the transitive verb. So this translation, let me just copy and paste it into where it should be on the left here. Ben is fond of tall trees. For all X, if X is tall and X is a tree, then Ben is fond of that thing X. So Ben is fond of the tall tree. So that's how we do that translation. I like this one because it shows how we can work with a noun phrase that has an adjective in it, and it shows how you can deal with proper names alongside a transitive verb. So if that one was a little bit tough, feel free to look at that again, or you can ask me about it on Canvas. Okay, finally, at least one spooky ghost scared Magdalena. This is our last sentence that I'll do for practice. Okay, at least one, specifically at least one, just means some. Okay, so we're going to say there exists an X, and the thing that we're talking about is this spooky ghost X. So spooky ghost has, what is it in it? It has an adjective and it has a noun. So this means there is some ghost or there is some x such that x is spooky. So spooky x, and x is a ghost. We have a universal, so we use the and we want that ghost to scare Magdalena. So we could use scared as our predicate, and what happens? Well, the subject, the ghost, scares Magdalena. So Magdalena is our object, we can call that M. And what is the ghost? Well, the ghost is subscripted by X, so X is the variable that is scaring M. So the translation for 18, there is some X such that X is a ghost and X is spooky and X scared M. Okay, this is another good one. It's very much like 17, but here we have an existential instead of the universal, and we have another quantifier that isn't just every or some. Well, it is some, but it is written in a way that it's not 100% apparent that it's some. Okay, that's some practice. You can try these on your own, pause the video, and I'll go through the answers now. John likes Susan. This one's simple. Maybe this tripped you up because it's simple. This is just a predicate likes JS. We don't have any variables here. We're not saying every or some. We're just saying two proper names. John likes Susan. This is written as likes JS. Next one. John has a cat. Okay, so I'll show some of these in full detail. So we can pull out a cat X, and we can paraphrase this as John has X. So when we do a full translation here, we're going to get there exists an X for and X is a cat. So there is some X such that X is a cat, and John has X. So has J, and the cat is X. If you want to use the full names in your translations, please feel free. I'm only shorthanding them with capital letters because I have to write these out, and I don't want the video to be an hour long. So John has a cat, there is some X such that X is a cat, and J has X. Okay, barking dogs don't bite. This is paraphrased as all dogs that are barkers do not bite, so this kind of talks about adjectives again. Barking dogs, you can consider barking to be an adjective here, or a CP, a relative clause, all dogs that bark, all dogs that are barkers. So barking dogs do not bite. I'm just going to translate all dogs that are barkers do not bite. They're the same thing. In fact, I recommend if you see a sentence like this, I'll paraphrase it first. It helps. So for all X, all dogs. So for all X, if X is a dog, okay, is it just if X is a dog, or is it if X is a barking dog? For all X, if X is a barking dog, then X does not bite. So we need to say for all X, if X is a dog and X barks, then it is not the case that X bites. So when we say barking dogs, we need to make sure that we specify that X is a dog and X barks. If we just say for all X, if X is a dog, that just means all dogs don't bite. But specifically, this is barking dog. So we're taking those two properties and we're using the conjunction on them to say this thing that we have X, it's a dog and it barks. Okay, next one. Either every fruit is bitter or every fruit is sweet. Once again, these are two sentences, just like example, what is it? 15. 15 at the top here. It's very similar to this, where we have two separate sentences. So we're saying every fruit is bitter. That's one sentence. Or every fruit is sweet. That's another sentence. So we can say for all X, if X is a fruit, then X is bitter. This means every fruit is bitter. So all X, if X is a fruit, then X is bitter. Or we could use Y now if we want, or we can use X. It doesn't matter. I'll pick a different variable. Why not? It doesn't make a difference. Or for all Y, if Y is a fruit, then Y is sweet. So this right one says every fruit is sweet. So now our translation is every fruit is bitter, or every fruit is sweet. For all X, if X is a fruit, then X is bitter, or for all Y, if Y is a fruit, then Y is sweet. One thing I'll point out is that X and Y can be the same, they can be different. It doesn't matter. It's just your choice. We could use x again, it does not make a difference. So remember, when you substitute things in, when you think about the universal and what the variable is, it only matters what it's binding. That's it. So x is only binding fruit x and bitter x. There are no restrictions in place that tell us if x and y have to be different or have to be the same. If x and y have to be different, we explicitly state that with something like x is not equal to y. That is the only case where x and y must be different. So please keep that in mind. We'll talk about that more in your exploration problem. You'll see that. Okay, every student heard some news. This is an ambiguous sentence. Either we have every student being the focus first. So for all x, if x is a student, I'm going to abbreviate here sx for student and n for news. So for all x, if x is a student, there is some news y, such that y is news, and x heard y, right? So heard x, y. That's how we could translate the first one. For all x, if x is a student, then there is some y, such that y is news, and x heard y. So the student heard the news. If you want to pull things out, it works very similar to the example we did with scope ambiguity. Same thing, quantified noun phrase, every student, some news. Pull those out in two orders and translate. So that is one interpretation. Let me put that there. I'll do the second one in red. This is where we pull out some news first. So we could say there exists a y such that y is news. And for all x, if x is a student, then x heard y. So that would be the second translation of every student heard some news because it's ambiguous. Okay, last one. No student likes any exams. So any exams is the same thing as all exams. No student likes, well, let's actually talk about this. No student likes any exams. So there is no student that likes at least one exam. So basically, this is saying that every student does not like all the exams out there. So there is no exam that a student likes. So when we translate this, there is no x, such that x is a student, and there is an exam y, such that, wait, there is no x such that x is a student, and some y, such that y is an exam, and x likes y. Okay, let me think about this again. There is no student x, such that there is some exam y, and x likes y. So this means that for every student out there, if there is an exam, then that student does not like that exam. Okay, I think it's a good idea also to paraphrase this. Because when we have a word like no student, and as I'm 40 minutes into this video, my brain is starting to get a little bit foggy, so this is both for me and for you. Let's actually think about this. I'm going to clear the entire screen up and I'm going to paraphrase this. Because if I say no student likes any exams, in a way I'm saying that every student does not like exams. No student likes any exam. So every student does not like exams. So for all x, if x is a student, then for all y, if y is an exam, then it is not the case that x likes y. Okay, so this is another way of translating this sentence. And you might be noticing, hold on a second. Not exists in x, exists a y in our first translation, for all x, for all y in our second translation. What's up with this? Why are both the quantifiers changing? Now, my answer to you for this is that we're going to see a little bit later in the videos, we have these equivalent logical expressions, and we can use De Morgan's and things to change things. But you can sort of see how paraphrasing a sentence can make it a little bit easier to interpret. So for all students, if X is a student, and for all exams, Y if Y is an exam, if X is a student and Y is an exam, X is not going to like Y, because every student does not like every exam. If we had an exists a Y here, exam Y and not LXY, what would this mean? What would this mean if we had this? This would mean then that every student doesn't like some exam. That's what that one would mean. Every student doesn't like some particular exam. So for every student, there is some Y, such that Y is an exam, and X does not like Y. But we're saying students don't like any exams. So every student does not like exams, period. That's why we use the universal. I think in this case, the paraphrase might be easier to interpret. But this translation below certainly works. So there is no X where X is a student, and there's some exam such that X likes that exam. Okay, yeah, 19F, that took a little bit to explain. I think it's a little bit of fatigue of going through the video. I'm sure you experience fatigue doing this too, but I think it's always good when that happens, because then I can take a step back in the video and I can say, hold on, let's take a look at a different way of doing this, a different way of paraphrasing it, and finding, hey, this is a real thing that happens. We take a step back, we find something that makes a little bit more sense, is a little bit easier to interpret, and we found a nice translation. And then we showed here why the alternative translation does not work. So I think actually maybe that might be a good thing to do here too. There's not an X such that X is a student, and for all Y, if Y is an exam, then X likes Y. What does this one mean? There is no student that likes every exam. So this one would be no student likes every exam. Okay, well, no student likes every exam is not the same thing as no student likes any exams. Because this translation, no student likes every exam, well, there could be an exam that they do like. They don't like every exam, they just like some of them. So that's how we know in this case that this one does not work. Similarly, in the other case that we looked at where the existential doesn't work. So yeah, I did pull you in a roundabout method with a little bit uncertainty when I translated it the first time, but we took a step back, we went through piece by piece, and we discovered, okay, that translation was fine because we found the alternative translation with the other quantifier that just doesn't have the same meaning. And then we did the paraphrase and we did sort of the same idea there. So yeah, long video, tough video. Translations are the hardest part of predicate logic, in my own personal opinion. That might be different for you. But if you have any questions, you know where to ask. Discussion board, email. I'll get back to you when I can. Good job for making it through the video. It was long.